Okay, so we've got this little cantilever sticking out with this dirt pushing up on it, and it's trying to shear it along this plane. So I need that dimension that's left over. How do I find it? It's logic, okay? You can use the equations if you want. If I take 84 and subtract 10 from it and divide it by 2, I get this dimension. 84, subtract 10, divide it by 2 gives me this dimension and this dimension. They're both the same. So 84 minus 10 divided by 2, 37 inches. If that is 37 and the first part is 14, so I'll subtract 14.6875, this has to be 22.3125 inches. That's what that equation does. You should get the same exact number if you use the equation in letter K. W minus WT divided by 2 minus D. That's exactly what I did. Okay, so what am I going to do? I'm going to use VU. So VU, this is K. VU equals factor design soil pressure, 2457. Times that little cantilever sticking out, 22.3125. 22.3125 in inches divided by 12 inches per foot. Why? Because that's pounds per square foot. If I take that and multiply it, I have a number that tells me what the shear force right along this plane is. So let's do it. 22.3, I'll clear that. 22.3125 divided by 12 multiplied by 2457. 4568.5. 4568.5 pounds. What do I have? Pounds per square foot here. Feet here. Shear forces in pounds. That makes sense. I like that. So there's what's actual. Now I got to go, just like we always do, what's the allowable? So that was letter K. L, compare it to the allowable. Allowable says 5 VC. Phi is 0.75. Multiply that by 2. Multiply it by the square root of the type of concrete, 2,000. Multiply it by B and D. D is simple. It's right here. B is always 12 inches. B is the distance into the board. And for a footer that is continuous, we're doing a 12-inch strip. And D, 14.6875. Now, if this number is bigger than 45, we're good. If it's less than, we've got to change something. So let me do it. 0.75 times 2 times the square root of 2,000 times 12 times 14.6875. 11,823. Oh, looks like I'm in good shape. This is allowable. That takes care of shear. Okay, so we're down through letter L. M says if this is bigger than this, we're okay. If it's not, you end up with a problem. You got to solve it. A couple things come to mind. Maybe getting better concrete. Better concrete will give a bigger number there. That'll give us a bigger allowable. That's probably the most logical. Another one is increase the thickness of the concrete? There are several solutions. The next is moment. So this is shear. The next is going to be moment. So we're worrying about it cracking for shear and cracking by bending. So we're on letter O now. Determine the moment about the plane of the face of the wall. So this is the shear. This is the moment. Okay? So we're bending it about the face of the wall. And we just had that as 37 inches right there. So this thing sticking out is 37 inches. I need that. And I've got that soil pushing up again at the same force, 2,457 pounds a square foot. So I want the moment. So let's go to letter O. O says find the force. How do I find the force? Multiply the force pushing by the area it's pushing on. So F is going to equal 2,457 foot deep, 37 inches sticking out. The 12 is changing the 37 inches into feet. I'm multiplying by pounds per square foot. So 2,457 times 37 divided by 12. 75, 75, 75. So I've got a force pushing right up right here. 7,500 pounds. Where does it push? It pushes in the center. So that force is acting in the center of the 37. Center of the 37 is 37 divided by 2. So the moment arm is 37 divided by 2. So the next step says, determine the moment. 75.75 is a force times the distance. I'm going to end up with inch pounds now. I want it that way. Notice, very common mistake on tests. Divide by 12 there. It's not the same thing. This is half of the distance. This is changing the units. So I got 75 times 37 divided by 2. 75 times 37 divided by 2. There's my MU as you've come to know it, okay? That's MU. If you look at the next step, it says take that and apply the resistance factor and get MT. So I'm going to divide that by 0.9. Divided by 0.9. I need that number. Okay, there's the moment. So the moment, trying to bend this up like a flap, is 155,724 inch-pounds of moment. So that got us through letter Q. So we're done with checking the concrete. Okay. In the next one, when we do a footer, we're actually going to compare that number to something. In this one, the rebar takes care of that. So the last one is the rebar, and then we're done. Two components of rebar. One is the main steel, the other is the longitudinal. So rebar is next. Okay. First one is the main steel. That's the AS. R, letter R. Area steel. This should look familiar to you. MT. The J doesn't, but everything else does. 155,724 divided by the type of steel, 40. This is in pounds, so this needs to be in PSI. J is a constant, and D is the 14.6875. Divide, you got it. 155,724 divided by 0.9 divided by 40,000 divided by 14.6875. There's the steel I need. I need 0.2945 square inches of steel for every foot into the board. I designed it for a foot. So there's one of them done. So this guy right here is going to be, what have we got there? It looks like it's pretty close. I'm going to put 0.30 square inches per foot. So that's what I need for this. Okay, that takes care of the lines going left to right. Now I got the dots. Okay, that is the longitudinal or the temperature steel. So it says, go to the table on page 449, which we'll do in a minute. T says, this is the area of steel temperature or longitudinal. Take your pick. Longitudinal says use a constant, multiply it by the cross section you see by looking at the picture. 18 by 84. That is the height and the width. Okay? Multiply them out, we got her. 0.0015 times 84 times 18 is 2.27 square inches. So if I add up all these dots right here, those dots right there, the area of steel temperature is equal to 2.27 square inches. Okay, all we've got to do is size them now. We've got number 5s. So let's finish it off. We're just about there. If you're taking, you go to page 449. Look at the table. Put your finger on a number 5 bar. Wander down until you hit 0.3. 0.3, 0.3, 0.31. Go to the left. It says put them at 12 inches on center. So this would go to number 5s at 12 inches center to center. Takes care of that one. And then we move up to the top. So this guy is number 5s at 12-inch center to center. Now, I'm going to use number 5s for the longitudinal. Use number 5s. If you go to the table on page 416, you're going to find out that the area of a number 5 is 0.31 square inches. Okay, if I put them in this configuration, the number of bars I need is going to be the total number of square inches of steel I calculated divided by the area of one bar. So if I take the 22 or 2.27, 2.27, I divide it by 0.31, I get 7.32. 7.32 bars. Can't have 0.32. So I need 8 of those little suckers. So instead of my 4 dots, I'm going to have 8 dots. 2, 3, 4, 5, 6. So this would be eight number 5s longitudinal. Okay, we got 7 foot to put them in, so it looks like to me they're going to probably be about a foot apart, going that way too. Okay, this takes us out of the unit associated with a wall footer. We'll be taping the one associated with a spread footer for delivery right after this. Once we get through these 2 lessons, we're done with your book. I've already uploaded the documents for the foundation, the slab and wall formwork. They're already in Canvas. We'll be going to those, so we've got actually 3 probably sessions to finish up. We've got one for tables, which is material stresses and loads. That'll be one lecture. Next lecture will be for slab, and the final lecture will be for walls and struts, which are the braces, the diagonal braces to hold the walls in place. So we've got left in the course, it looks like when you get done with this lecture, we've got the spread, and we've got spread, we've got wall forms, we've got slab forms, and we've got braces, and then we're done. In between this, we've got tests. You've got a test that is going to cover this and the foundations, and the wall and slab forms will be the very last test. So take a look at it. If you have questions, hopefully this answers them, and we'll jump into the spread footers next time.